Hello, welcome to the third section of solving this final exam of ESM course. Hope you have gone through the part A solutions. There were two recordings. I would like you to follow the sequence solution 1, 2, then 3 so that I assume that you have already gone through those so that I will not repeat what I have already told most of the time. Okay. So let us now look at the part B solutions. This is nothing to do with the assembly program. Maybe you can try writing the assembly code for this, but you will have problem in assigning such a big number to any register. I will tell you what to do just for the information, but it may not come as a part of the exam later on, not now. Here, what you are supposed to do is find the solution of this particular sequence of operations. It's only to give you a practice on using the C operators. Assuming that the variable that we are having is an sint, which is signed integer, just a name doesn't make sure that it is a signed integer. It should be declared as a signed integer. And we are assuming that it has already been initialized with this value. What I want you to find out is after these operations are performed, what will be the result written into sint. Okay, there is nothing to do write any assembly code here, only to evaluate this expression. Assuming that the sint is a signed integer value and it is a 4-byte value. Okay, it's 32-bit size is 32-bit. Now let us look at it now. Okay, fine. I think we will look at this now. This variable, which is sint, is initialized with 0x. Let me write this ff and then 1 f2 f3. So this is actually a 4 to 16-bit value, and this is another 16-bit should be. I left a gap here just to make sure that you understand that I have not actually written all the entire 32-bit value. Okay, you might make a mistake here that it's a 32-bit quantity, but it's not. See, what is a normal convention is, if it is all filled with zeros, the higher part is left with zeros, filled with zeros, normally in a hexadecimal form, that value is not written. Now, for example, if I say 0x1, I can also write 0x01. I can also 0x001. What it means, 0x1 means it's a one value 1 in hexadecimal, and then if I say that it is a 32-bit quantity, then what really it means that I have all zeros from bit 31 to bit 1, and bit 0 is 1. Okay, that's all it means. So I can write it in any form I want. So the zeros which are there, this leading zeros, normally are dropped out. So in this case, one entire hexadecimal value 0 is dropped off. Okay, so this corresponds to a 32-bit quantity. Okay, not only this one. This one corresponds to 28-bit. Okay, that you should remember. Okay, this value is stored into sint already, and then we want to do this operation. Now I am not going to write it again. See here, what is shown here is the innermost parenthesis. So always when the C compiler looks at, or any compiler for that matter, looks at the quantity to be evaluated, it always computes the value within the innermost parenthesis. Okay, function call is different. That function call also has fn, and then some function call is a parenthesis, but that will be treated separately. But in an expression, the innermost parenthesis is evaluated. So when you are looking at it, you need to do that first before doing this right shift of 2-bit. Okay, you have to have something, some value on the left side for you to do a right shift of that operator. Now one more thing you should remember, if one quantity of this particular expression is a signed integer, then the entire thing is treated as a signed integer number. Okay, that's another second point you should remember. Then third one is, what is the size of this sint? Suppose if it is a 64-bit machine and then I am compiling this for a 64-bit processor, then this sint could be inside internally when the processor is operating on it, it will be operating on a 64-bit quantity. Okay, so in our case RP2040 we are assuming, and I have also told you that it's a 32-bit signed number, so we are going to treat it as a 32-bit number. Okay, that's the important thing. Now what is the value we have? This is the value we have, which is going to be left shifted by 4. Now when I am shifting it by 4, left shifting, you remember left shifting always brings in zeros here. Okay, there is no arithmetic left shift or logical left shift. Left shift will always bring in zeros inside from the right side. So now how many bits I am moving? 4 bits. And you know that every hexadecimal number is 4-bit wide. In binary form it will be represented as 4-bit wide. So it is very easy to write it down. What will be the value when I shift it by 4-bit to the left? There will be 1 0 added here. So I can rewrite it here. Okay, after the left shift by 4, this ascent, okay, I am writing it like this. Ascent will have FF 1F. Okay, this I always want to group it in 4, and then maybe you can leave a gap. Okay, anyway, so that you don't make any mistake. So this F is gone, then 2 is there. 2F3, then 4 zeros would have come here. Okay, I am writing it in hexadecimal, so maybe write it as 0x. That means 4 bits are zeros which have been moved into the from the right side. So this is what I am doing it. So the rest of the quantity, if you see FF1, F2, F, okay, maybe you write it as F3, F2, F1 and F. The same quantity is there because when it is moving inside, nothing is going to change, and it will exactly come and fit into this 4-bit. This 4 will come here, 4 bits will come. So this will be 0. That's all. Now this is the operation which is performed, and what is the value? This is the value which you will get. I hope this is clear to you. Now what we are going to do is, after doing this, we are going to do a right shift by 2. Since this is a signed integer, remember you need to know this F, or it could be 8 or anything more than 8, the MSB is set to 1. So you have to immediately understand the binary representation of this number to see whether the MSB bit, which is a signed bit, set or not. In our case it is set. Okay, maybe I will so this FF is this and MSB is set. This is MS, most significant bit. Okay, maybe capital bit means byte, so MSB, so most significant bit. If it is sign bit is set, it's a negative number. It will be treated as a negative number, and I am going to shift it by right 2. Now what I should do, if it is a signed integer, I should perform a arithmetic right shift. Okay, arithmetic shift by shift ASR, arithmetic shift right. I'm not just telling the instruction, but we are not going to do the assembly instruction. We are going to do physically moving these bits. So in this case, we are moving it only by 2 bits. So we need to be careful that we don't mess up with the number that we are getting. So it is better you write it down in binary form. Okay, so let me write it out. Okay, FFF 1F. I am leaving a gap between 2 byte nibble values. 2 F 3 and 0. Okay, I hope there is no doubt. I am not put anything more than that. 1 2 3 4 5 6 7 8. 8 into 4 32 bit. Okay, so F 1 F 2 F and 3 0. Now what am I supposed to do? Right shift it by 2. Then what happened? I don't have to rewrite everything. Okay, please remember that you don't have that much of luxury of time, though 2 hours are there, but still I want you to be smart enough not to waste time when you can actually do without performing rewriting the whole thing. 2 bits are right shifting, then these 2 are gone. Okay, they are going to be dropped out. Now what will be coming in? That's very important. 2 bits will come in. Whether it will move, this one what is already there will go as it is. Now only what is coming in, will it be 0 or 1, depends on whether you are doing a right shift of a signed number or unsigned number, because we are saying that it is a ascent signed integer. and the MSB has is happens to be 1. So that will be copied. So two ones will be added. Please remember, two ones are added. That's all. Now we are going to ignore this. We are going to consider this as a 4-bit, 32-bit quantity. But you have to group them into 4 because I want to write it in hexadecimal form. So I am going to divide it into 4 because you can start from anywhere, but I am starting from here. Okay, I will not touch the value so that okay, this is 4-bit. Okay, we got it. Now I need to write it in hexadecimal form. Let me write 0x. This is F. This is F. This is C. 8 plus 4, 12 C. This is 7. This is C again. This is 8 plus 3, 11, which is B. Then this is C, again C. F of C7, C, B, C, C. Okay. This is after the quantity which is right shifted by 2. Entire thing on this side of the OR operation. This is what you have. Now, what is there on the other side? I have now this is a OR operation I have to do. Okay. I hope this is not another one. Yeah. Okay, there's a cursor. Okay, this OR operator is there, and then rest of it is to be, it's a 32-bit quantity which is to be, this tilde is a NOT operator. So let me perform that operation. You want to do a tilde 0x FFF, write it down once because you should not make any mistake here. This is what I have written, 4F and then 2F and EE. If I do a NOT operation, what will happen? So this is 0x. This is all ones. You can directly write it in a hexadecimal form only, no problem. But here, don't try to do it in hexadecimal number because you are likely to make mistake. So let me take that EE, okay, EE separately, these two bits, these two hexadecimal values, write it in a binary form. EE is what? E is 1110, 1110, 1 less than F, right? So 1 will be 0, that LSB will be 0. If I do a NOT operation, what will happen? These 3 bits will become 0 and this will be 1. So this will be 1. Okay. This is after the NOT operation. Now this value you got it. These are all hexadecimal number. Please remember, I am not leaving out the 0x. Now let me take out another color. Maybe black we are not used for long. So let me do black. Now I want to write, we want to do a OR operation. It doesn't matter whether you do this or versus this, or you can write it in any order, right? So this value what we found, I am going to write it. F C, okay, 7, F of C7, CB, this B, C, C. Now I am going to perform a OR operation. Okay. Now again OR operation, remember we have to perform that OR operation here. This is very straightforward. All zeros are ones. It will result in F. Now anything, actually you don't need to do anything here because zeros are there. So this value same 7 C7 will come. Wherever zeros are there, you can just copy whatever is there in the below. All ones will be preserved, right? All zeros will not have any impact. Now, whereas here you cannot just say that, you cannot say D it will become, or no, we don't know. It could become D, but still better to write it out. Okay. Now I have this in binary form, so let me make use of that binary form. C, I know 8 plus 4 is 12. C is this, right? If I perform an OR operation, 1 1 0 1, it will be 1 1 0 1. What is it? C plus 1 D, right? So this is D. Now this is the value you will get when it will be returned. Now I said that write the answer in both hexadecimal and binary form. So I have written it in hexadecimal form. So since the question is asking us to write it in binary form, no harm in just writing it. It doesn't matter. It doesn't take much of time. You should be very comfortable in converting it. Okay, sorry. I'm saying that I'm making a mistake. Okay. C 7, this 1 actually, okay, and then C is 1100, B is 1 less than C, okay, 1 more than A, so A is 10, 10101. No, this after this one we have to write. Let me erase it. I don't want too many mistakes here. Okay, here also I will erase it and write it properly. Okay, what was this? This is F, this is F. C is 1100, 7 is 011 3 ones. Okay, C is this correct. B is one more you have to put. 8 plus 2 is 8 plus 2 10 A, and this one B. D is C plus 1, which is already here. So 1101 1101. That's all. Okay, I shouldn't take more time. I am writing it later. That's all. Is 1 is done. Okay, 11, question 11 is done. Okay, that's for question 11. Now this question 12 is very straightforward. um, Pin mode is setting this to input mode. That means the GPIO. So please remember the numbers what you are giving inside them is GPIO number, and this setup is going to be executed only once in the beginning, and it is setting up the GPIO 4 as input mode. That means you can give either 1 or 0. That means very high 5 volt or 0 volt, and then 5 is given as an output. That means you can connect a 1 kilo ohm resistor with a LED, then it will glow when you write a high into it. So this GPIO number 5, I have mentioned it already. Okay, now digital write. Now inside the loop, this loop is going to be called infinite time from the Arduino IDE framework, and it will make it low first. It means the LED will be off, and then it will delay it by 400 milliseconds. It will be sleeping for 400 milliseconds. That means it's going to be low for 400 milliseconds, and then the same pin number is made it high, and then it is going to wait for 200 milliseconds. That means it is going to be low for 400 milliseconds and high for 200 milliseconds. So you will see that every 600 milliseconds something is happening. Okay, some blinking is happening, and then I am declaring a variable int reading the 4, from 4, because I cannot write into 4 because it's set as the input mode, and we are reading from the value. So if you feed a 0 or 1 or a high voltage or a 0 voltage, it will be read, and this value will be either 0 or 1. So you have to write it in a short form, but at the same time explaining this. I don't want to write a page. At the same time, one paragraph is enough. Compress it and write it in the single line. What I can give an example is the GPIO number 4 is made as an in the input mode, and the pin GPIO number 5 is made as set as an output mode, so that it can be connected to a 1 kilo ohm resistor and a LED. Then loop is going to be called infinite times from the IDE framework, and it is going to be the LED will be off for 400 millisecond, then it will be on for 200 millisecond, and it will continue forever. Then you say that every loop, it is also reading from the pin number 4, GPIO number 4. If you give 1 or 0, based on that, this value will be changed. That's all you need to write. It shouldn't take more than a paragraph. Fine. This is going to be there, this question. I just want to make sure that you understand that setup is going to be called once, and loop is going to be called from the framework infinite times inside a while loop, which is infinite loop while 1, and this is going to be executed forever. Okay, and the delay is a sleeping for that much of millisecond. That's all you have to mention. Okay, now I want you to write an assembly program which computes the average of 4 parameters. Okay, what are the 4 parameters? Parameter 1, 2, 3, 4. You are writing a assembly code, remember. Okay, assume that all the parameters are of unsigned type. So we have declared, when you are writing assembly, compiler knows whether it is generating it for an unsigned number or signed number. But now as a human being, we are writing the assembly code. So we should be told whether we are to assume these values as signed number or unsigned number. So now I am saying that these are all unsigned numbers, and I am returning an unsigned result after finding the average of these 4 parameters. Now how do I write the code? Okay, so let me keep it up. Okay. Now we are going to solve. Okay. I'm sorry. Okay. Now let us change the color. I want the blue. Okay. Fine. We are going to solve question 13. Four parameters are coming in. So I have to write assembly means my average ESM. Please follow whatever is the convention. This is the function we are writing. Colon. Okay. Colon. There is no gap here. Okay. Colon. Now you don't need to write. You have to assume that param 1 is in R0. Okay. 2 is in R1. 3 is in R2, which you are all aware. The parameters are default copied into these registers before the function control comes here. Okay. PC is set to this particular instruction. Now when you are here in assembly code, already the R0, R1, R2, R3 are copied with the parameters which have been passed by the C function. Now what am I supposed to do? I'm supposed to find the average. Now to find an average, I need to add them all, right? So I have only these registers which I can use. Okay, you remember we can't use any other register. Can I manage with only these registers? Let us see. Now what I do, I need to add two numbers, and one more thing you remember, I can't put all these three registers as three different registers. It's not allowed. Okay, because in Cortex M0 Plus I can use only the registers, two unique registers in this three. Now what is this? It is actually equivalent to comment is hash is a command. R0 is filled with R0 plus R1. So I have added these two numbers now. Where the result is, it is in R0. Now what should I do with that addition? I should add this, right? So what should I do? Add. Take in, actually when you are writing it, write from the right, okay, like Arabic language, right from the right side. So let me give two operands which are R0 and R2. I am adding the sum which is already available in R0, because I said R0 plus R1 equal to R0, which is available in R0. So I am taking the previous two sums, these sums, adding with R2, the third parameter which is available in R2. And where should it go? I can overwrite it in R0. Please remember, once I use R0 value, I can overwrite it with R0. Please remember that. I am not writing into R0 without using the value which has come in. Okay. Because I have to manage with whatever registers I have. Now what happened? I have added up to this. Now only R3 is pending. So let me add that also. I take the sum of three registers which are available here. R3 is the fourth parameter, and I can write the result into R0. Now I have found the sum of all these four numbers. What I need to do, I need to divide it by 4 to find the average, which should be available in R0 because it is returning an unsigned integer there. Now how do I do a division by 4 easily? I can do a div instruction which I have not told you actually. So please remember, I can use another instruction which is dividing by 4. I have to do a left shift or right shift. See, one simple example, if you don't remember, take one example 0 1 0, which is a equivalent binary number is 2. If I am dividing by 2, what am I doing? I am doing a left shift or right shift. The quantity should become lower. 2 by 2 should become 1. That means I have to shift it right, so that 0 0 1 it becomes, so I get a 1. That means I am reducing the position value from a higher position to a lower position. So I am dividing it. If I am multiplying it, I would have moved it to the left. Now, while I am doing a right shift, I should be clear whether I have to do ASR, shift right, or LSR. I have to decide this, because I don't know what value will come as R0 in R1 and R2. We can be a huge number. Okay, you don't decide what value is coming in, because people using the C function will be deciding that, right? So I need to now decide about whether I have to use ASR or LSR. And what is it here? Unsigned integer it says. Okay, it says I am using unsigned integer. That means I don't need to use ISR, and not only that I don't use to, I should not. Okay, I should not use ASR, because if I get a huge number, maybe where MSB is 1, and then if I use ASR, I am going to make it larger than what it was, or maybe I will continue to have a larger value. It will not come down at all unless I move in 0 on the MSB side. So it should be LSR. Please remember, based on the type of the variable, you have to choose one of this whenever I am doing a right shift. Now right shift I am doing, why? Because I want to divide it by 4. How many right shift I should do? By 2. If I do only one right shift, it is equivalent to dividing by 2. If I do 2 right shift, it is equivalent to dividing by 4. Okay, so I will divide it by 4 by right shifting it by 2. Then I have to use LSR. Now what am I doing? I am taking the R0 value, which is having the sum of all the 4 numbers. How many times I want to do the right shift? I want to do 2 times. Okay, got it? And then I need to write the result into R0, because I do a right shift of LSR and then write the result into R0, because I need to return that unsigned value out. And then what should I do? Very simple. I have to have a BXLR, where I have to return branch exchange with link register. That's all. This is what you have to write. Okay. I hope this is clear to you. Now, what is this? 14th question. Let us move it up. Maybe let us change the color. Q14. Okay, write an assembly program. See, ARM assembly program, because it can be any assembly, but you all of us are reading learning assembly, ARM assembly. I'm giving Mali assembly program example because you can also actually change these values. No, unsigned number, signed number. This value you can change. Many of you are asking for a practice problem. Very simple. Imagine yourself that you have been given a different combination of this, and then how will you write an assembly code for it? So try writing it, and if you have a walkthrough simulator, you can actually run the code on it, or if you really have a board also, Arduino or Raspberry Pi, you can run it on that. So, or physically do that operation and verify it, or check with the others. Okay, so that's how you practice more problems, so that you get a practice. Now I said that ARM assembly program for to evaluate the C expression. Earlier we just evaluated it. Now we are going to implement it in ARM assembly, and assuming that SVAL are all both signed integer variables. Okay, I am saying signed integer. Now I am not asking you to compute the value, because we are not assigning any value to SVAL1 or SVAL2. Only thing is, we are saying that these are all available as parameter, first parameter, second parameter. That means you have to assume that this SVAL is available, SVAL1. Okay, let me write it. SVAL1 is available maybe in R0, not maybe, it is. And then SVAL2 is in R1, because it is coming as a first and second parameter into the assembly function. So I want to write assembly function. I have not given any name. So you are free to use any label. My ESM function, maybe question 14, okay, and colon. That's all. You have done the label now. I am already assuming that SVAL1 is passed into R0 and SVAL2 is available in R1. Now what do I do? And I told you, as compiler, you have to think like a compiler, because you are going to generate the assembly instruction. What will you evaluate first? You have to evaluate this, right? This one first. It doesn't matter which one, but you can go from left to right, and then you have to do this, then perform an AND operation. Okay, and actually, to be precise, I should have one more parenthesis, because precedence wise AND operator is performed first and then OR. So assume that there is one more parenthesis here, or we'll give it to you in, you do it from left to right here. So you perform this operation, perform this, then compute the AND operation. Then with that, find the NOT of this and perform an OR operation. That's all you have to do. Okay. So let me now go one by one. Okay. Let me move this little bit. Okay. So create a space for me. Now what do I do? I have to do a left shift by 5. There is only one left shift. Okay. Which is LSL instruction. Left shift, logical shift left. Okay. LSL. And where is it? Where val1 I am doing it. So it is R0. Right. I am capital right. I am writing so that you know there is no ambiguity in which register I am using. And then how many bits I am doing it? 5. Immediate value 5. So don't try to copy this value to another register and waste your register values and then more instruction. Okay, you can always write with a simple immediate value. Okay, left shift by 5. Then I cannot perform an AND operation immediately. I need to do a right shift now. Now which right shift I should do? Is a signed integer value. So arithmetic shift right I have to do. But no, remember that. So ASR, which one? R1 I have to use. Remember the register that you are using. As I told you, always write the operand first before getting the result. And then you have to say, I want to do it by 3 bits. Then where do I write the answer? I will put it in R1. Done. Now I have reused the same R0 value, but without disturbing or without losing that value. I have made use of it, and then I left shifted it by 5 bit. I wrote it in R0. Right shifted this by R1. I wrote it in R1. I have these two values. Now where is this 1F? It is not coming as a parameter. It is given to you that you need to perform the OR operation with the not of 0x1F. Now 0x1F is only one nibble is given to you. You don't need to compute the actual value of what it will happen, but you should remember that there is a instruction called MVN, move negate. Okay, so there is an instruction called move negate. Okay, now I may be able to do that move negate with the immediate constant, but if you are not sure whether it is there or not, I always let us assume that one more instruction doesn't matter, but as long as it is correct, it is better. Even if MEN with the immediate constant is not there, or if you are not even sure about it, then don't guess it. Now I need to move 0x1F because it is with a small number which can be moved with the normal move instruction, 1 byte value. Now where do I move it? Because this R0 and R1 are already holding some valid values. I cannot disturb them. But R2 and R3 I am free to use it. Okay. So let me root R2. Okay. Let me use R2. What do I move? I move 1F. Okay. Actually, sorry, I should use 0x. Okay. Let me write 0x. Otherwise there will be a assembler error. Okay. 1 0x 1F. Okay. This is 0. Okay. I moved it into R2. Now I can confidently use MVN, move negate. What I do, I move the value R2 by negating all the bits. That means I am doing the not operator of 1F which is already in R2. Okay, not of R2 I am doing. Now, which will be again I can move it into R2. I do always remember it is a right to left movement. It is coming here. So complemented and moved to R2. Now I have that ready now. R2 is having that value. R0 and R1 are here. Actually now I deferred the AND operator which was here. I could have done it, AND operation I could have done it here also. Okay. Let me choose. I could have done AND operation here, but no harm in performing it here also because I am not disturbing the values in R0 and R1. Okay, so let me move it. Now R0 and R1 I need to perform an AND operation which is highlighted there in the top. So instruction is AND. Now which are the input operands? R0, R1. It doesn't matter what order you give. Okay, as long as AND operator is you can do it in any order, and I can write it into R0. Let me write it into R0 because finally I want the result to be available in R0. So let me move it to R0. and operation is done. This complete this left side is done. On the other side of the OR operator, I am ready with the value in R2. Now I need to perform OR operation. Now remember that there is an instruction called ORR. It's not outer ring road, it's OR operation. Okay, because normal convention is three mnemonic, three character mnemonic. So ARM decided to have it as ORR. Now what do I do ORR with? R2 and R0, I need to do a ORR. So I write R0, R2. Remember, always I am in the three parameter, two are same, okay? That I am taking care of. I cannot put three different registers here. And then I write it in R0 because I want the final result to be in R0. Done. I have done the OR operation also. Now I want the result to be returned. Return the result. Okay, this function returns the result. So R0 is having the result. So I need to return now DXLR. That's all. Your job is done. Okay. So I will show you the complete code. I want you to practice with different instructions on the operator or operator so that you get used to this assembly programming. Now I think we have exceeded the time limit, so I would like to stop here and then continue in the next lecture. Okay, see you in the next lecture. Bye bye.